D.4, hints for homework 1, part 5. The last part for hints for homework 1. We have 3 questions. Question number 21, 22, and 23. First one, number 21. It is known that the fraction of the execution time for a task that can take advantage of enhancement is f. So that is our FEN in our standard formula. After the enhancement, so this one, the fraction of the execution time for the enhanced part becomes 2/3 f. It is known that overall speed up is 2. What is the value of f? So this question, you can see the conditions given. We can set up 2 equations. Because there are 2 unknowns. The first one is f. There is another one hidden, so we cannot see directly, but if we understand the background of this type of questions, we know that. So that's the S, local speed up. Local speed up. Okay? Yeah. All right. We have a similar question in our comprehension question set 2, module 2, part C, question 7. So the structure the same, just some numbers slightly different. So we can use this one, the solution of this one, so you can easily understand how to solve question number 21. We draw diagram. The task divided into 2 parts. Enhanced part F, non-enhanced part 1 minus F. So this is before enhancement. All right. Then the second part, shorter. That's after enhanced part. All right. Non-enhanced part, the same, 1 minus f. Enhanced part, f over s. Okay. Then, by the given 2 conditions, we can set up 2 equations. All right. So the first one, after enhancement. Here, after enhancement. Fraction of execution time. So 1/2 f equals f over s. The enhanced part over total. Total, including enhanced part plus non-enhanced part. That's the equation. Then speed up, overall speed up, our standard formula, 2 equals 1 over f over s plus 1 minus f. So this equation, 2 equations, 2 unknowns, and you can solve it. When you solve, try to find an efficient way to solve. Do not, because here, consider the denominator of these 2 fractions are the same. Try to use that information. So then, actually, if you look at one of the examples in our notes, similar to this one, one of our examples in the notes similar to this one. But if you can solve these 2 simultaneous equations easily, you can just do the same thing on this question number 21. Not very hard, but you need to understand the background, why we do it in this way. All right, so that's the first question of this video. The second one, the second one, so this question, there is one special way to apply our processor performance equation. So I want to explain that part. Otherwise, this question is not very hard. In a program, the frequency of floating point operation is 40%. And the average CPI of floating point is 3.2. If the frequency of the floating point square root operation is 8%, and the CPI of the floating point square root operations is 10. How much is the CPI of the non-square root operation that are floating point operations? So that question. Here you can see we only consider the floating point operations. We do not consider non-floating point operations. Within the floating point operations, there are two parts. So then we look at those two parts. Okay, so that's the situation we have. We have a similar question in our comprehension question set 1, module 2, part B, question 6. So in this one, only the numbers slightly different. Pretty much the same. And we have the solution. In our solution, we use this formula. But this formula, I want to explain a little bit. Because here you can see we use the frequency of floating point here, 60%. If you just consider our original processor performance equation, original processor performance equation. So it's very easy you missed this percent number. You missed, very likely you may miss it. Because if you apply this formula directly, so you just put the frequency here, and you forgot to put here. So let me help you understand. So why we should put this 60% here. First, the first view, understanding for this situation, think about if you just put 10% frequency here, 50% frequency here, the total frequency you add up, 60%, not 100%, right? 60%, not 100%. So then, but if you put 100% left-hand side, then not quite compatible, right? Not quite compatible. At the right-hand side, you only count 60% of the operations. But left-hand side, you consider 100% operations. That's not compatible, right? So for that reason, you should put the total sum of the frequencies at the left-hand side. So in that way, so then, left-hand side, right-hand side, you are looking at the same group of operations. Otherwise, you look at different groups of operations, right? So now you look at the same group of operations, floating point operations. So that's the reason. All right. So in general, so that equation we can write frequency FFP times CPI FP equals FPSQR times CPI FPSQR plus F non-FPSQR within FP times CPI, the name is a little long, PSQR within FP. Okay, yeah. In this way, then FP equals the sum of these two frequency numbers. Then both sides, you are looking at the same group of operations. Then compatible, balanced. Yeah. Otherwise, uncompatible, not balanced. Okay? All right. Yeah, in our next question, we will use this same formula. Yeah. Otherwise, you miss something. Yeah. You will miss this frequency. Yeah. All right. The last question I want to talk about in this hint part. Question 23. Yeah. When we improve the performance of a program, we examine the operations in this program. It is known that the frequency FP given 25%. Frequency FPSQR 5%. If we can reduce frequency of, if we can reduce CPI of FPSQR by 4 cycles per instruction, how many cycles per instruction can we reduce for the average CPI of this program? Yeah. For this question, we have a similar one in our comprehension question set number 1, module 2, and part B, question 8. Yeah. Although if you compare two questions several places, not quite the same, but the underlying method is the same. Yeah. So here I just work on this comprehension question example, so you can get idea, yeah, how to solve. Yeah. All right. So in this comprehension question set example, yeah, CPI of FPSQR improved by 2. Okay, improved part. Yeah. CPI of FP improved by 1.2. And the overall CPI improved by 0.48. What is the frequency of the FPSQR operations? In the solution I give you, it's pretty long, pretty long. Yeah. Some steps may not be necessary. Yeah. Here, I like to give you a simplified version. Yeah. Because some of the steps we can skip. So we do not have to repeat, all those steps that we don't need. Yeah. All right, so here, let me consider the case. All right. First, CPI. Yeah, because here we have the CPI, overall CPI. So we need to write that overall CPI equation first. Okay, so CPI equals F frequency of FP times CPI FP plus frequency non-FP times CPI non-FP. That's the first equation. Then, because when you see improve, that means there are two versions of this equation. Old one, new one. Yeah. New one improve against the old one. So we need to take the difference of the two equations. When we take the difference, because here I do not want to, copy the equation twice, right? In my solution, I give you in the comprehension questions, I copy twice. Okay? But here, because after we understand what we are doing, we can skip some steps. Here, I just take subtraction directly of old version, new version equations. Subtraction, the difference of CPI old and CPI new, I use delta CPI. Delta CPI. In math, delta means difference. Okay, so we frequently use the delta symbol represent difference of, two similar variables. CPI here. Two versions of CPI. And when we take the difference, the second term is gone, cancellation. Because old version, new version, the second term, exactly the same. So we can cancel out. Then we only need to look at the first term. The first term, frequency part, there is no change. FP delta CPI FP. Okay? So this is our first difference equation, delta version difference equation. Now we need a second difference equation. Okay. The second difference equation, we start with the equation I gave you in the previous question. Previous question I explained. Okay, left hand side, right hand side, compatible, balanced, right? That version. So let me write it another time. So that is related to the floating point operations. We write this version. FP times CPI FP equals FP SQR times CPI FP SQR plus the second term FP SQR, none, within FP times CPI non-FP SQR within FP. All right. Now, because we need to write this equation, old version, new version, and look at the improvement and take the difference. When we take the difference, second term gone. Okay, so then F frequency part no change. So FP times then the delta CPI FP equals FP SQR times delta CPI FP SQR. See? Yeah. Now we have two equations, this one and this one. All right? Yeah. Now, when we connect these two, you can see the right-hand side of the first equation equals the left-hand side of the second equation. Same thing. Yeah. Then, if we do substitution, we have delta CPI equals just the right-hand side of the second equation. FP SQR times delta CPI FP SQR. So this last equation, that's what we need to get the answer for this question. Yeah. All right. Delta CPI. What is delta CPI? Yeah. Delta CPI. What's that? Overall CPI improved by 0.48. That's the delta CPI. Okay. Yeah. And what is the delta CPI FPSQR? CPI is improved by 2. Okay. Yeah. So 0.48 here 2 here. Then you can easily find F frequency of FPSQR. Yeah, the solution. Yeah. That's for the, our comprehension question set. Yeah. Yeah. So a lot of steps you can simplify. You do not need. Yeah. Here you can also see this 1.2 we don't need. Right? You can see, in our last equation we only need that 2 number, 0.48 number, but we don't need that 1.2 number. We find the solution. Now, then you can go back to look at our homework question number 23. You are pretty close to the solution. If you understand this whole story, you can easily solve our homework question number 23. Yeah. All right, so that's everything I want to explain in our homework assignment number 1. Yeah. All right, so let me stop this part right here.